Let's set up our REST API and connect it to our database. Let's begin in our terminal and let's connect to the Ubuntu server where we have our database running. Once we're in there, what we want to do is clone our GitHub repo. I'll list the folder so you see that I already have it cloned, but just to show you how to clone the repo, I'll make a folder called temp and then I'll cd into that folder, and then I will copy the entire path. Another way of doing it is to browse to the project GitHub folder, the project GitHub, and then copy that. But basically, if you run git clone, it's going to clone the entire project. Right, and now if you list, you'll have the same thing that I have. I've already done some work outside to save us some time, so I'll go back there and I will go into the cloned GitHub repo, and then I'll list the folders. You see we have up to chapter 6 here, and then I will go into the chapter 6 folder, and then I'll go into my API, and now I can list everything that we have. I'll list it in a longer format, and so you'll see we have app.js as a file, and then we have bin as a folder, skip over node modules and packages, then we have public routes and views. Right, now we can take a look at our package.json. I'll use the cat command for that. Previously, you saw me do that from a text editor. And this should look similar to what you've seen previously. Now, before we can work, we need to run npm install just to be sure that we have all of our modules installed and up to date. Next, we need to go to our routes folder. So remember, that's one of the folders we saw. And again, we can list everything that we have in there. Now, there's a new file called dbcon, and that holds the connection credentials to our database. And we can list it. This is what it looks like. And I have an app called Nano installed that I can use to edit this if I need to, so I can go through and edit everything. And when I'm done, I can use Ctrl-O to save and Ctrl-X to exit. Now clear the screen. So next, let's take a look at our stations.js, and I'll use Nano this time around. Not that we're going to change anything. And so you can see our declarations at the top, express and router declared on the first two lines. And then we have our MySQL database connection, which points to our file dbcon, and then we have a router.get definition, which will get our station listings. and you can see our query in there. We have stubs for post, put, and delete, but we're not using them here. So we'll just leave those empty. Basically what we're doing now is getting our station listing. So I'll use Ctrl X to get out. Actually, I will update this with our most recent code. Because we need to be able to write to it, so just a second. Okay, I don't need to update stations. Let's look at readings.js. That's the one that. Okay, so that has our get for returning our readings or fetching them, and then our post for writing into that. Both definitions exist. We have a query here for our post. In our post, we're making use of a prepared statement, and you see that towards the end where we have these question marks. And then when we call the query and we pass in our query, we have to use this array to pass in the values that will be replaced within the prepared statement. So when we want to do an insert, we need to specify our station ID, the epochs, the temperature, and the humidity, and we do that with an array here. So that's how our prepared statement is going to work. So note towards the end that we've got this results that we're getting back from our query execution. We also get an error. If there's an error, then the API will throw an error, but if there isn't, then it will give us the results, and the results is basically what gets returned when we write to the DB. Right, and we're almost ready to run this, so I'll exit this screen. And so we've seen our stations, our readings, and our dbcon. So let's go back one more step and let's take a look at our app.js. And we're not editing anything here, so I'll use cat app.js. And so we have the entire code listed out. And in this section here, you have the app.use that specifies our routes that we're using and the files that we point at. So we're now ready to run this, and so we'll do that using a command that you're already familiar with, my API. Okay, so we have this listening on port 3000, and what that means is we can go to Postman and test our APIs. So let's do that. We've got Postman here, and we just need the get method, and then we need to specify the IP address of our server, our port number, which is 3000, and then the endpoint that we want. In this case, we want to get readings. And you can go ahead and hit send. And lower here, we have the readings that we already have in our table. And you can just choose to inspect any single reading that you want. And so we have our station ID, our epochs, our temperature, and our humidity. And this is what we would have put in. So we can go ahead and simulate what our microcontroller is going to be doing. And so this time around, we specify that we're doing a post into that API endpoint. And so we need to send in a payload. And so I'm going to copy a payload across, and the payload just needs to look like one of these. In fact, you could just choose to copy one of these, but we'll get rid of the ID. We don't use that. So we'll go to our body tag, and we'll specify that we're using raw, and then we'll specify JSON, and I'll paste this and get rid of the ID. We don't need the ID, that's auto-generated. I don't need this at the end. I just need to be sure that everything is properly formatted. So we have a station ID, we have an epoch, and I'll change that. I'll just put 1 here, even though our system will replace that with the correct thing. Temperature and humidity are the important values, and this should work when we hit send. And that's it. We have our result here. Field count 0, affected rows 1. That means 1 row was inserted into our table. Insert ID is 15. And you can note this because if we get back and do a get, the entry with ID 15 should have a temperature of 30.5 and a humidity of 65. And so let's do that. Let's go and get. And we use none and send this. And so we have everything returned, and you see the most recent entry is 15, 30.5, and 65. We have our correct date here, which was put in for us, 2023, November 6th, which is the date at which I'm recording this. Right, so we're all set, and we can configure our microcontroller to send readings to this database using this API endpoint. So I'll stop the recording here, and then we'll continue with another recording. Let's send sensor readings to our database via our REST API. I've got the Arduino IDE open, and we're going to be making use of the Maker Wi-Fi 1010. We've got our includes at the top of the sketch. We're making use of the ENV shield. You've already seen us attach the ENV shield to the Maker Wi-Fi 1010 in previous chapters. so we're not going to do that. We also have an Arduino secrets file where we specify the credentials for our Wi-Fi. In this sketch, I'm going to be taking sensor readings every 15 seconds. That's just so that we don't have to wait too long to see new data get into our database. The definition for this is on lines 7 and 8. On lines 10 and 11, we define our variables for holding our temperature and humidity. Those are on line 10, and on line 11, we define our station ID. This is usually going to be a constant because the microcontroller and the shield aren't moving around. On lines 13 and 14, we fetch the Wi-Fi credentials. And on line 16, we define our Wi-Fi status to be idle. On line 17, we specify the IP address where we have our REST API running. So that's our server. On line 18, we specify the port number. If this is running on port 80, you can change it to that. And then on line 19, we define an instance. We define our Wi-Fi client on line 19. Within our setup, we go ahead and start our serial monitor. And then we check to ensure that our ENV shield is connected and that we can initialize it. And then on line 28, we check that we can connect to Wi-Fi. If we're not connected, we attempt that on line 29. And then we check the status. And as long as that status is not connected, we just wait 10 seconds and we keep trying. And once that succeeds, we output connected to Wi-Fi. I'm going to get rid of this test code that I put here just to confirm the IP address. Okay, within the loop, we do this every 15 seconds. We check for the last time that we ran this particular loop on line 39, and then we can read our temperature and our humidity from our ENV shield. We can print that out to the serial monitor, and then we stop any connections that we have to our REST API, and then we attempt a connection. We attempt to open a new connection, and if that succeeds on line 49, we then proceed to create a payload. So if you recall previously when we tested this out with Postman, we had to send a JSON payload. So this is where we create that payload in our Arduino sketch. So we start on line 50 and we create the payload, and then we need to put in the various elements within our JSON payload. So we need a station ID, which we add in line 51. We just send in 1 for the epochs in line 52. 53 has our temperature and 54 has our humidity. And then we need to do something called stringify, and we do that in line 56. And then we just send out some debug information to the console on line 58, where we specify that we're connected to the server and we're now about to post data. And then all of that activity for posting the data happens from lines 61 all the way to 68. Now, if all of this fails, we need to let ourselves know when we're in debug mode. And that's it. We're ready to upload the sketch. So I will turn on my microcontroller and try to locate it. Yeah, it's up. So select that and we can upload the sketch. wait for it to finish uploading. It's done uploading, and then we can open our serial monitor and observe for a connection to our Wi-Fi network. So we can see that it's attempting to connect to the Wi-Fi. Give it a few seconds. And it's connected, and I'll just expand this a bit. So we see it's connected to our Wi-Fi. We can see what our current temperature and humidity are. And it's connected to our server, and it's posting data, and it will do this every 15 seconds. And what we can do is go to our server and check for these temperatures and humidities. It's a good thing that we're getting slight variations now. So when we check, we can look for the last set of entries that are 48.5, 47.5, and 47 for the humidity. So let's go over to Postman. And we already have our settings. It's get. We have our URL endpoint. I'll just hit send. It'll fetch new data. I'll scroll to the bottom and take a look at our humidity. And it's a little bit more granular here, but we can see 46, 48.45, 47.4998, which we could round up to 47.50, and then 46, 46, and we can go back here. Yeah, and that's kind of what we're seeing, right? The 46, 46, 47, 47.50, 48.45. And that's it. Our microcontroller is writing to our database. It's writing to the API endpoint, and you can go into the database and confirm that you've got data. Clearly, we've got data because when we do a fetch from the API endpoint, we're seeing all of that data. That's it. Thank you.